So Stephan and Mathieu will explain a bit the context, but we've been at EPFL working on space sustainability now over 10 years with the Clean Space Initiative, and also with the start of the research initiative on sustainable space logistics in 2019, that also led to the creation, well, the hosting and the launching of the space sustainability rating also last year. And now we are happy also to, I would say, gather all the different projects related to space sustainability at EPFL within the Sustainable Space Hub. And for that, there will be Mathieu Udriot from eSpace and Stephan Hellmich from the Lastro laboratory that will present the hub and what is behind this organization. So thanks everyone. If you have questions throughout the presentation, you can ask within the chat, and you can also at the end raise your hand, and there will be a Q&A session. Also be aware that the seminar is recorded, so if you don't want your face to be shown, then don't put your camera, or just be aware that we're recording the seminar. Thanks very much, everyone, and then Stephan and Mathieu do the presentation.
Yeah, hello everybody, and thanks a lot for the introduction. And as Emmanuel already said, in today's seminar, we are going to present the new EPFL Sustainable Space Hub that is hosted here at eSpace. And just before we start, just in case if you don't know us, a few more words on who we actually are, so Mathieu and me. And please don't be confused that there's right now you see my face with Mathieu's name under it. It's just we are using the same computer and sharing the presentation, so we will switch at some point and then it will be corrected for. So Mathieu graduated from EPFL with a Master in Microengineering in 2022. He was also part of the EPFL rocket team, and since he graduated, he is working as a young professional here at EPFL Space Center, where he's currently working on 2 projects funded by ESA that are dealing with the life cycle assessment to better understand the environmental impacts of launchers, and modeling space logistics for the feasibility studies for future missions. He's further supporting student associations, and in case we ever have to call the fire brigade, it might be Mathieu coming for your rescue, because he's also a volunteer firefighter here at EQ Blocks. So for me, I did my degree in computer science in 2011. After that, I was working at the Institute of Planetary Research at the German Aerospace Center, so DLR, in Berlin, where I also did my PhD studying the long-term orbital evolution of asteroids. I was further working on characterization of minor planets of the solar system, and that involved a lot of observations, and it turned out that many of the methods we were using to characterize like minor planets in the solar system can actually be used for applied to space debris research. So, and this is precisely what I'm doing now here as a postdoc at EPFL since March 2022. So I think this week I will have my first anniversary at EPFL. So, and one cool thing when working as an astronomer is that you're going to spend time in the mountains, and you can actually enjoy the mountains during daytime when you can't observe. So, yeah, just a little bit advertising for the job that involves night work, but yeah, at nice locations. So, as we already said, today we are going to present the Sustainable Space Hub, which is the EPFL's, or will become EPFL's competence group for new technologies and service to secure long-term sustainability of space. So this hub is meant to bring together people from many different projects and labs within EPFL that are related to space sustainability. And our goal is to increase awareness of the debris situation in near Earth space, study the environmental impacts, and develop tools to identify technology gaps and support sustainable mission design. And by connecting all the different projects here at EPFL and all the labs, we will support research, education, technology development in this field within EPFL. So this is our global picture what we are working for. But before we are going to present all the groups and projects here at EPFL, just a few words on what the current debris situation in Earth's orbit actually is. So in this diagram, is showing the number of objects in orbit, or how the number of objects in orbit increased since the beginning of space exploration. So there currently are about 25,000 trackable objects around Earth. And due to collisions and anti-satellite missile tests, that result in a dramatic increase of debris. The current satellite missions, they are endangered by these debris. And also the deployment of mega constellations such as the Starlink constellation, they result in a steep increase of active spacecraft over the past few years that you can see here in the blue, the blue curve in the diagram. And looking at the number of spacecraft launched per year illustrates even more the dramatic trend that we are having or we are facing in the past years. If you take into account the upcoming launches, it is clear that this trend will continue in the future. And so the Starlink constellation alone will result in a 10-fold increase of satellites in orbit. So the current situation is so dramatic that the safety of active satellites in Earth orbit can only be ensured through precise tracking and surveillance of the depopulation and collision avoidance maneuvers by active satellites. So this diagram shows how the future collisional evolution of objects in LEO or low Earth orbit will be simulated by ESA. And in red, there's the evolution if we continue as we did in the past, so business as usual. And in gray, if we completely stop all space activity. So it can be seen that even if we stop launching new objects into space, the number of collisions and also the number of debris will increase for centuries. So all this led us to a situation there where if we don't change our behavior, we might lose the access to certain orbits within the next decades. But that's not even the whole story. Space exploration has not only implications on space environment, but also down here on Earth. So there's parts of launch vehicles that fall back to Earth, or also parts of spacecraft that survive re-entry. And there's still toxic substances, mostly in oceans, but also in populated areas. Further, there are a lot of unknown impacts on the environment and the atmosphere from emissions during launch. And space exploration also starting to influence astronomy. So this picture was the NASA astronomy picture of the day in June 14, 2022. And it shows the scenery of the Nambung National Park in Western Australia. And all the streaks you can see in the sky of these images are created by low Earth orbit satellites reflecting the sunlight. And they were captured in less than 2 hours of exposure and digitally combined into one single image. And looking at this image, you might imagine that astronomical observations are already impacted by resident space objects. And in fact, there was a recent study by some astronomers from ESO that tried to estimate the effect of the upcoming mega constellations on astronomical observations. And they found that for an observatory at mid-latitude, there are about 1,600 satellites above horizon at any given time. And out of those, there are 1,100 illuminated during twilight. So that is during beginning and the end of the night. And out of those, there's over 150 that are above 30 degrees of elevation. So this is where the astronomical observations usually are made. And this means that for currently used large aperture wide field telescope, about 1 to 5% of the exposures during twilight are affected by satellite rays. And for upcoming very wide field telescopes like the Rubin Observatory, there's up to 30% of the data that might be lost. So now you might think scientists are clever people. They can find places there are measurements are not influenced by environmental impacts or effects. But it seems like Earth's orbit is about to lose this quality. A recent study revealed that there are a growing number of images taken with the Hubble Space Telescope that are affected by satellite trails. But I mean, right now, these numbers are not dramatic, but the trend is clearly increasing. But satellites are not only affecting optical observations. Active satellites are also radio sources, and that they can have significant impact on radio astronomy. And there are only a few places on Earth left that are still suitable for radio astronomy. So scientists already think about, so where can we go? And right now, like the far side of the moon would be a valuable location for radio telescopes. But with the upcoming lunar exploration projects, the far side of the moon might lose this quality as well. So, and as you can see, these two articles, they are like from last week. So this is really an urgent matter. So within the hub, we are trying to find an answer to the question how we can foster space activities while sustaining the use of outer space in the long term. So I mean, there's a lot of benefits from space mission, and we don't want to stop space exploration, so we want to foster it. But we also need to find a way to keep Earth's orbit usable for future generations. So what can we do about this? So how can we achieve this goal or answer this question that I just described? So we could stop launching, but if you remember the diagram showing the number of launches in the past years, it is clear that this is not going to happen. And we also don't want it to happen because all the benefits we have from our activities in space. Second thing we can or we have to do is like increase the sustainability in space, which means like until now or right now, there currently are very poor international regulations concerning sustainability in space. And the efforts for more sustainable use of the space are just starting. We have to promote these efforts. And we finally eventually have to do active space debris removal. And therefore, we would need to identify the dangerous objects that have to be removed and develop the technology to safely remove them from orbit. So now that I've introduced you to the topic, we are going to present you the individual projects related to sustainability in space here at EPFL. And so there's Mathieu and me, but of course we are not the only, we're only like a small fraction of people that are working in this field at EPFL. There's many more labs and people, as you can see here. And the topics studied at EPFL include like range from debris characterization, active space debris removal, studying reentry and hypervelocity impacts. Further, there's the space sustainability rating, sustainable space logistics, space architecture that focus on improving future space exploration, and also taking account the social aspects of space exploration and exploitation. But it is not only the people you see here that are doing all the work. There's a substantial contribution also coming from many students that are doing their semester projects, master and PhD thesis on one of these projects. And there's also the EPFL SSA team that is working on surveillance and tracking of space debris. And in case it happens that you are working on a project that you think is relevant but not mentioned in this presentation, please don't be offended, but let us know and become part of Sustainable Space Hub. So we are imagining this hub to rest on 3 intervening pillars to measure, understand, and act for improving sustainability in space. Measure to fill the knowledge gaps about space objects. Understand to analyze measurements, quantify risks and impacts of space missions. And finally, use all this knowledge to act and to implement techniques to solve the most urgent problems and implement guidelines to promote sustainable behavior in the future. So, but first of all, what do we need to measure and what for? So we would need to know the current state of the debris population and to evaluate the current situation in the first place. So we need to. So this is important for risk assessment for space missions, and also important when you want to define mitigation measures. We need to know the attitude, state, and the physical properties of space debris or space objects. And this is very relevant for target selection of active space debris removal missions, or to detect imminent rotational stress-induced fragmentation events. So things are coming apart if they rotate too quickly. And also, it's important to study the long-term effects of the space environment on space objects. We further need to measure launch emissions, test propulsion systems, and evaluating the different types of fuels, measure the emissions from rocket launches in the atmosphere. So, for example, flying or to make in situ measurements from within the plume, or use satellites to remotely track the emissions. And we also need to evaluate the impacts on the society, like the impacts of space exploration and exploitation on the society. So in order to better understand the current state of this debris population and to do this physical characterization, we are currently developing methods at EPFL to detect and analyze space debris on large astronomical data archives. And therefore, we are currently focusing on the archives of two large telescopes. That is the ESO VLT, the Large Survey Telescope, and the Blanco Telescope, both in Chile. And these telescopes that gathered data for a decade that resulted in a huge archive of hundreds of thousands of images, and they have been never looked at for space objects that are crossing the field of view. And you can see here on the right-hand image how the space objects would appear on these images, and they are just crossing the field of view and causing streaks. And in this example, the streaks were caused by Starlink satellites that just after launch, while they're still close together and on their way to their final orbits. So they're crossing all together the exposure. And to make use of such observations, we are developing techniques to efficiently detect the satellite streaks on the astronomical images. We have to identify the detections with the known objects, which may sound more easy than it actually is. And we need to implement methods to do photometric measurements of the streaks in order to obtain light curves. So these light curves, they are basically time series of brightness measurements that contain information on the tumbling state and can further be used to reconstruct size and shape and even physical properties of the surface material of the observed targets. And further, to follow up interesting targets and to do our own observations, we are working on enabling the Telesto telescope, which is located at the Observatory of Geneva, for space debris observations. This image has been taken with the telescope about 3 weeks ago, and it demonstrates how bright a space object can appear on astronomical images. So this star here in the lower part of the image is a star of magnitude 5, so it would be visible by naked eye, even if the observing conditions are not ideal. And the bright streak in the middle is caused by the Blue Walker 3 satellite that was launched last year and deployed a 64 square meter antenna, making it brighter than 99.8% of the visible stars in the sky. And as already explained, the orbit around is quite crowded. So it happened just by chance that there was another satellite that caused a second trail on the image. And that turned out to be from the Global Star Communication Network, launched in 1999. And this image now demonstrates like the effects that these new generation communication satellites will have on astronomical observations. And Blue Walker 3 is only a test satellite. The whole constellation will consist of 168 such satellites. So we will expect many, many more to come. And as I already mentioned, there's also a lot of students working in the field of space sustainability and space situational awareness. For example, there's the EPFL SSA team that spun off from the Callista Astronomy Association in 2020. They are focusing on space surveillance and tracking, and they can rely on about 20 active members. They are recently purchased their own telescope and are now planning to set it up at Astroval Observatory close to Lac de Joux. And the projects that the association currently is working on include precise orbit determination for collision probability calculations and physical characterization of space objects. Besides these ground-based efforts, EPFL is also supporting active space debris removal. So as you might know, the EPFL spin-off ClearSpace 1 will be the first mission to remove space debris from orbit. And the methods required to safely approach and capture an uncooperative target are developed here at EPFL. So this is done at CV Lab at EPFL, and they are currently implementing and improving neural networks for 60 pose estimation of space objects. So 60 pose estimation means that to find location and orientation of objects on images. And in order to use this technique for active space debris removal, the methods must be able to work with previously unseen objects, as the appearance of the targets might have been altered due to fragmentation or long-term influence of the space environment. The methods further have to work on images of objects that's in space, so they need to be generalized to this new domain. And finally, they have to be optimized to work on space hardware, because the capture process itself will be an autonomous process that is performed by the spacecraft. And the projects I've been talking so far were mostly focusing on the first two pillars, measuring and analyzing the problem. But there are also many other efforts within EPFL that use this information to develop guidelines to actually improve sustainability in space and to implement tools for more sustainable mission design. And all these projects will now be presented in the second part of the presentation, where I hand over to Mathieu, and with whom I'm co-leading this up. And yeah, floor is yours.
Thank you, Stephan. Oh, nice switch of screen. Okay. Yeah, thank you very much. So the first project I would like to talk about today is the Space Sustainability Rating, SSR. It's been mentioned by Emmanuel before. So the SSR was an initiative of the World Economic Forum back in 2016, and it's been created by a consortium of entities to encourage space actors to design and implement sustainable and responsible space missions. The rating itself is made of several modules. Each of them focus on one aspect of the definition of space sustainability, for instance, space debris risk or collision avoidance capabilities. And EPFL Space Center is hosting this rating since 2021 and has made it operational just last year. So the first rating are issued to space companies all around the world. And SSR is in the process now of becoming an independent association, but still recognized by EPFL. So eSpace will provide support in research and development to increase the scope of the rating, in particular by creating new modules or new rating systems, which I will present just now. So the first idea is called the Dark and Quiet Skies module. This is very much related to what Stephan presented before, that space missions have increasing impact on the astronomical observations on ground and in space. And so the word dark in the title here refers to impacts on optical astronomy and quiet for radio astronomy. And for that, we are supported by the CPS, who are experts on the matter. And we have 2 students working on it this semester. The point of the module is to include these aspects in the rating and to reward spacecraft operators that are making an effort to mitigate their impacts on astronomical observations. For this second module, here we'd like to extend the scope to also assess environmental impacts on the Earth environment. And for that, we would like to use a life cycle assessment methodology, which is a way to look not only at the global warming potential, for which we are very familiar with a CO2 equivalent unit, but at many other types of impacts. So for instance, ozone depletion, air acidification, toxicity, or resources depletion. And this assessment is made along the whole life cycle of the system or of the space mission. So through design, production, launch, use to disposal. For that, we also have a student working on a master thesis right now, and we get the support from the Strathclyde and Delft universities. Then the Launch Vehicle Sustainability Rating, LVSR. In that case, the point is to make an entirely new rating system focused on launch vehicles, because we realize that launchers are the impacts of launchers are not really captured by the current formula, although most of the impact of the space debris risk in orbit are coming from rocket bodies, so leftovers, upper stages of a rocket that are crossing, some of them geostationary and low Earth orbits, so it makes them really dangerous. We have a first formula for this rating that we have tested with mock data, and we are now also doing beta tests with voluntary companies to improve this rating, and we have a student working on the topic. Okay, the second research project I will mention is the Sustainable Space Logistics. This one is built on a lot of heritage here at EPFL, because as was mentioned before, a few years ago, we had the spin-off from EPFL ClearSpace that will be doing the first active debris removal mission in a few years. And also in 2019 to 2021, there was the research initiative on sustainable space logistics. So we are continuing these research topics for the same motivations as before. Plus, we add here the logistics aspect that space missions are getting more and more complex. As you see on the right-hand side, current and future exploration missions will have many more nodes, so more destinations. Also, new types of vehicles, new technologies that will enable new types of missions, like, for instance, in situ resources utilization. And the point of this research is to model space logistics, identify technology gaps, and better understand what sustainability is for a space mission so that we can include these aspects very early on in the design of a space mission. You also see on this image from the European Space Agency that there are many types of vehicles, a lot of activities around Earth with constellations, for instance, but also now a lot of activities towards and around the Moon and toward Mars, which makes a lot of space traffic. So in this topic, eSpace has been developing software tools to analyze the situation and better understand it. So the first one I will mention today is called TCAT for Space Logistics Optimization. A user will define the type of mission they want to achieve and which vehicles they have at disposal so that the tool can output the total fleet that they need. So the number of spacecrafts and launchers they need to actually achieve the mission. For each of those spacecrafts, there will be a plan computed, so a sequence of maneuvers and phases in orbit that the spacecrafts have to follow, and also a set of key performance indicators to be able to compare different simulations with different inputs, so that to be able to trade off the missions and select the best one in the end. The point is also to identify technology gaps. So if we see that one technology is missing, that would enable new types of mission. For now, the tool works for constellation deployment and also active debris removal missions. And we are looking into extending this with new logistic use cases. Okay, the second one is the assessment and comparison tool, ACT. Here it focuses on really performing rapid lifecycle assessment of launch vehicles. And for that, a user will have to define in the input side what materials, processes, and propellant are used, and also define some other required inputs like the ascent trajectory of the launcher, the mission profile in space, and all the ground logistics, so the different transport from production sites to the launch pad. And using lifecycle assessment databases, the tool will compute an impact score for different categories. So if you remember the diagram before for lifecycle assessment, not only global warming potential, but also others that are relevant to space missions. In that case, we also try to include the risk generated by space debris so that it's also taken into account in the assessment. The point is to identify environmental hotspots, so elements or phases of emissions that generate the most environmental impacts, so that it can help also making decisions to design new elements or change the design, so it hopefully reduces the total impact on the environment without shifting the burden. Also with this tool, we have identified knowledge gaps. So the science doesn't have the answer to everything yet. We don't know yet the impacts of emitting in the upper layers of the atmosphere, for instance. Or what if we discard a stage in the middle of the ocean? What is the impact on the ecosystem? This will have to be also better understood. There are other projects at EPFL on the topic of sustainable space logistics. I will mention two here. So first, the reentry. It was mentioned before that the number of spacecraft in orbit will increase, number of launches, which means also the number of reentries will increase, because deorbiting an object is a common way of getting rid of it at the end of mission. It frees up some space for the next objects that will be launched, and it also reduces the risk of collisions in orbit. But the models that try to predict how the spacecraft will break and burn in the atmosphere are still with a lot of uncertainties. And there's some research in particular at the LPAC laboratory to better understand how the materials react when they re-enter the atmosphere and demise. This will also help to understand their impacts, because these new particles and smoke in the upper layers of the atmosphere will indeed have an impact on the environment. A second project is at the LSMS lab, also at EPFL, where they try to model how material reacts to hypervelocity impacts. So I can remind you that in space, relative velocities of two objects can be of thousands of meters per second. So it's important to understand how the material will react even with a collision with a very small fragment. Then a very brand new project here at eSpace with the arrival of a senior researcher, Shanyat, that will be working on space sustainability, policy options, and interrelation with Earth system governance. So it's more also looking at the social aspects of space, trying to better understand the social economic benefits of space activities, in particular for developing countries. Also investigate future scenarios, how this will evolve, and try to use this knowledge to help decision makers in international organizations to make evidence-based decisions. So in order, for instance, to have a positive impact on the UN SDGs. Shan is also the founder of the Earth Space Sustainability Initiative, which has a lot of great synergies with the upper project. And here also she tries to broaden the definition of what space sustainability means. Okay, this final project called Concurrent Engineering is really at the core of the Pillar Act. If you remember the 3 pillars we have defined for our hub. So concurrent engineering is a process where we try to gather experts of different subsystems together in the same room, and they have to together in parallel design a system. It's called concurrent engineering because actually they all have conflicting requirements, and they have to try to work together as a team, take decisions by consensus, and share all their data to have in the end a system that works with all the separate subsystems. This is a process very much used in space industry, in particular at the European Space Agency, because it helps in the early phase of the design to really understand the feasibility or not of a space mission. So to set up our concurrent design facility here at eSpace, we've used actually education as a mean to advance our knowledge. We've participated last year in the Concurrent Engineering Challenge supported by ESA. And in just a week, we will start the new course, ENG 411 at EPFL for master students. Teaching them these concepts also helps us to maintain our knowledge. And ultimately, we would also like to offer the use of our CDF as a service to research partners and external companies. We would like to do so also by integrating our knowledge about sustainable space. So all the tools that we have developed could be used in design studies. There could also be experts on sustainable space that participate to those studies, so that not only the traditional trade-offs between mission performance, cost, or time can be done, but also we could include all these aspects about Earth and space sustainability or even social impacts very early on in the design process of a space mission. Okay, we are getting to the end of this presentation. Thank you for staying with us to the end. To summarize, I will just come back to the problems that motivate the creation of this sustainable space hub. So we've seen that there are environmental risks, both in space with the space debris and on Earth with all the environmental impacts. And so society, as we know it, is highly dependent on space activities. So the hub tries to answer this question of how we can foster space activities that bring a lot of benefits while keeping sustainable access to space also for the generation to come. The hub is built around the 3 pillars to measure, understand, and act. And the point of this hub will be first to develop new collaborations, also here at EPFL, to understand which labs and teams are working on the topic. So just like Stephan said before, if you have a research project on one of those topics and you would like to be closer to the Sustainable Space Hub, just contact us and we can also add you on a brand new Slack that we have created. Also, all of this will be used to support research at EPFL and ultimately to transfer our knowledge to industry and agencies to actually have a positive impact to design more sustainable space missions in the future. So thank you very much for your attention. And I think now if you have any questions, we can also answer. Thank you.
Thank you. I don't see any question in the chat. Maybe Emmanuel wants to say a few words. If anybody has a question, you can also raise your hand. I will unmute you. And if there's no question, then I guess it was so clearly explained.
Great.
That was really clear. Yeah, no, that's true. Okay, then I guess. Oh no, one second. There is an applause, not a raise hand. Question, anybody? No.
We also accept appraisal. No?
Yeah.
But it's also very much Mathieu and Stephan for this presentation. I think it's good because there's a lot of, I would say, good work on identifying different technologies and work that has been done within EPFL and to also enhance this work and to communicate also around this. So that's also very important, and also very, very happy that we completed the team with Shine Yap, who joined us earlier this month. And so we have great plans ahead of us. So stay tuned also for the future Sustainable Space Hub updates.